We're going to finish up chapter 9 today. So we ended up on the slide, but we didn't finish it. So I'm starting on this slide. But again, bases that contain carbonate, carbonate is CO3 with a -2 charge, or hydrogen carbonate, which is HCO3, which has a -1 charge, they'll react with an acid and they become carbonic acid. And this is what I was talking about when rainwater goes through the atmosphere, it combines with carbon dioxide and produces carbonic acid. Okay, so that's why if you collect rainwater, its pH won't be 7, it'll be more like 6, okay? Carbonic acid isn't real super stable, so eventually it'll decompose back down to water and carbon dioxide. But it does combine, water will combine with it to produce carbonic acid, okay? They do this, they can make carbonic acid like bubbling. When you guys buy pop, you know, the carbonation, that's carbon dioxide bubbled in there. So you get, because you have water in your pop, you're also going to get a little bit of carbonic acid formed, or another acid they use is phosphoric. So if you tested the pH of like Coke and stuff, you'd find out it'd be down like about 2. Okay, it's definitely an acid. Okay, but this is what happens. Um, you know, you've got your water going down or your hydrogen ions, and they combine, and this is what carbonic acid's formula is, H2CO3. So you can see it's really water plus carbon dioxide. And again, that's why when you have rainwater, that its pH is going to be a little bit lower than 7 because it combines with the carbon dioxide in there to produce carbonic acid. Here's it in reverse. Here's carbonic acid, water, and carbon dioxide. Okay. Okay. If you get heartburn and you take antacids like Tums and so on, they have carbonate ions, and so they combine with the acid in your stomach and they neutralize it. Okay, so that's why, you know, Tums and all those work to neutralize acids. If you take the other ones like Prilosec and those are different. Okay, they stop your stomach from producing acid. That's a different thing. But an antacid like Tums and can't even think, Rolaids, there's another one. When you chew them up, they have carbonate in them and they dissolve, or they react with the acid in your stomach to kind of tone it down to neutralize, and then your heartburn goes away. Okay. All right. So we talked about acid bases. You can take an acid and a base and put them together and you'll get this strong reaction. Okay. And you'll get two neutral substances, which is really nice. Okay. Here's some that happen in your body. Ammonia, NH3, is a base, and it'll react with amines, which have nitrogen in them, and they'll form salts, ammonium salts. So again, it's a way of your body neutralizing things. Here's a base. Here's epinephrine, which is adrenaline. When you put it with HCl, which is hydrochloric acid, you end up with this. And again, this is going to be neutral. These are organic reactions. I'm not expecting you to memorize them, but the thing to remember is we have all these neutralization reactions occurring in our body. Our body just does it naturally, okay? So the reason why we have a reaction like this, they use it to solubilize amines. In other words, to make them much more soluble so your body can get rid of them. Okay, and so they're of, you know, pharmaceutical. You know, they're interested in that because again, that's something that they can use in their medications to help. Okay, now we also have things called buffers. All right, if you took 2 glasses of water, one glass had just distilled water and one had tap water. If you added a drop of sulfuric acid to the distilled water, the pH after like 2 drops would go from 7 to about 2. If you do it to the tap water, it would take probably 40 drops of sulfuric acid for that to happen. And the reason is tap water has buffers in it. It has ions that'll absorb the acid. Okay, so a buffer is a solution that helps resist change in pH. It neutralizes the acids and the bases. And there's a lot, we have a lot of these buffer systems, you probably don't even know it. If you buy juice, look for them. A lot of times they say citric acid, and then they'll say sodium citrate. That is an acid, a buffer system. Okay, because when you drink juice, you know, there's a lot of acid in juices, and it could be kind of hard on your tummy. So if you have a citrate buffer in there, that'll help. Okay, I've heard lately on a commercial for it's something you got to get a shot of. I can't remember what medication it is, but they said we removed the citric acid buffers, and I'm not really sure why they would do that, because buffers are good things. Buffers help keep things kind of level. Okay, a buffer is basically a mixture of a weak acid and its conjugate base, and it helps absorb either hydroxide or hydronium, whichever one, and so that you don't get these huge changes in pH. So that's what a buffer does. It buffers things. It keeps things kind of steady, okay? And so if an acid is added to a buffer, a base will neutralize it. So again, buffers help just make sure that things don't get too out of whack fast. It takes a long time. Now, you can add and add and add and add, and eventually the buffer will be used up, and then you'll have drastic changes in pH. But the buffers make it a lot more. 2 drops as opposed to probably 30 drops. Again, and you can try this sometimes if you want. But here's some other ones. This is in your body, you have the phosphate. That's a buffer that you have. Hemoglobin, your red blood cells have a buffer on them. So you have all kinds of buffer systems. And again, their job is to help just keep things steady so that you don't get these drastic changes in pH, okay? So an acid added to a buffer, the base will neutralize it. If a base is added to a buffer, the acid will neutralize it. So they just work opposite of each other. But again, their job is to just keep things kind of level out so you don't get those drastic changes, because drastic changes aren't good, especially if you're talking about in the human body, okay? Oops, sorry. Here's an example again. Here's a buffer and its system. You add a small amount of hydrogen, the weak base component of the buffer will work together, and you can see you use up your hydrogen, okay? It uses it up. So again, a buffer just helps keep things kind of level. So again, oops, sorry about that. A buffer here, we have equal quantities of both the acid and the base, and then we add a little bit more acid. But because the weak component can absorb that acid, you still don't get that huge change in pH. Okay, so that's what a buffer does. It's kind of a weak acid or base that helps absorb either the hydrogen or hydroxide and make sure you don't get drastic changes. Okay, we have buffers in our bodies. You can actually measure the of an acid or a base, their buffer capacity, how much they can neutralize. The greater the concentration of the buffer components, the greater its capacity, its buffer capacity. So buffer capacity is measuring how much can it absorb before there's an issue. And there's some equations to figure that out. We're not going to worry about it. If you take my General Chem 122, we do the actual, but we're just going to just know that a buffer capacity is how much can it absorb before you get drastic changes in pH, okay? So the addition of acids and base, again, in excess of a buffer. Once you reach its capacity, then you're going to get that drastic change in pH. But until you get to its capacity, it'll still absorb and absorb without drastic changes in pH, okay? We have normal buffers in our body. We have an acid-base homeostasis. If you don't remember what homeostasis is, that's the balance that we have in our body. Okay, our body likes to have everything at a certain level. Our temperature, our respirations, our heart rate, our blood pressure, all that things likes to be at a certain level. And we kind of try to do what we can to maintain it at that. That's homeostasis. Well, you have a buffer in your body for acids and bases because, again, we want our pH to be between 7.35 and 7.45. Okay? Buffers, there's a whole bunch. It's not just one organ that does it. Okay? Our lungs do it by breathing because, remember, we get that carbon dioxide in there, and carbon dioxide will produce carbonic acid, and that'll lower it. So we breathe it out. Our kidneys are wonderful. You know, they buffer out a lot of stuff. They take care of that, so they regulate our balances, okay? So again, like I was talking about with lungs, they take care of the carbon dioxide, that extra carbon dioxide, because we don't want to produce carbonic acid. If we get too much carbonic acid, we're going to lower our pH, and that's not good, okay? Your kidneys take care of a lot of that. They'll get rid of some of those substances that are floating around in your blood. Your kidney is basically a great big huge filter, and it just takes out that nasty stuff, and then we excrete it through our urine. So these guys are great buffer systems to help us keep our level where it should be. Okay, so again, organs, I guess, act as buffers. So again, we talked about acidosis. It's a condition where your pH drops too low, and this happens with people that are diabetic. It's probably the most common that'll get acidosis, okay? And it's caused by blood pH dropping. It's not good. Okay, this can occur also with your breathing. And some of you might have experienced this if you've ever hyperventilated. Now, they say the best thing you're supposed to do when you hyperventilate is just sit and relax and get your breathing back to normal. But it's hard because you have been getting too much. They need the carbon dioxide to help you get back into your respiratory normal rhythm. So a lot of times they'll give you like a paper bag to breathe in. Okay, that'll help it. Honestly, I've heard that that's not a good thing to do. I've heard just, sit, relax, get your breathing back to normal, but, okay. There's metabolic acidosis, and again, that's when you're diabetic, or people that starve themselves will go into metabolic acidosis. This is much more serious. This is just, sit, relax, catch your breath, you'll be okay. This, not so much. There has to be some serious medical intervention for that one. These have to be controlled by, like I said, intravenous infusions of hydrogen carbonate, a buffer. You got to absorb that carbon dioxide, take care of that, okay? So again, this, sit, relax, okay, you're back to normal. This is hospitalization, okay? So again, we have alkalosis. So we have acidosis if your pH gets too low. Alkalosis, again, when you're breathing too rapid, like I said, it'll cause carbon dioxide to remove too quickly, because we need a little bit of carbon dioxide in there. And so what happens if you don't have enough carbon dioxide, then your pH goes up. So if you want to get it back down where it's supposed to, you're supposed to breathe in carbon dioxide. And that's what I was telling you about the paper bag. Okay, you breathe in the paper bag. You're not breathing in as much oxygen. You'll get the carbon dioxide, and supposedly it's supposed to reverse that carbon dioxide level. Again, I've heard various stories. Yeah, it's good for you. No, it's not good for you. Sit down, relax, breathe normal, whatever. But sometimes you just can't. So if you've ever hyperventilated, you know what I'm talking about. Okay, so metabolic acidosis can occur. Oh, this is supposed to be alkalosis. Sorry, you guys, this should be alkalosis. Can occur if you take too much antacids. Some people, I don't know, they like the taste of them, I guess. Or sometimes you have adrenaline gland diseases. One's called Addison's. I think President Kennedy had that. There's some other things, that'll cause some issues where and again, this is where they're going to have to medically take care of it. It might be, you have to take some sort of medicines. You might have to get some IVs, something like that. This, yeah, breathe a little bit. So acidosis can be either easy or bad. Again, sometimes there's an easy fix, sometimes not so easy. But again, it's due to buffers. Okay, our body has normal buffers, and it can control most of it. Okay, here you can see if you're really bad with your acidosis, they will actually give you dilute hydrochloric. This is alkalosis. I'm sorry, you guys. This should say alkalosis. They'll give you dilute hydrochloric acid to get your pH back where it's supposed to be. Okay, so that's it. We are done with chapter 9. Okay, keep up the good work, you guys.